So here is a question that basically they have given us this skeletal structure. Okay, so now what we need to do, we are going to draw its displayed structure. So if we are going to draw its displayed structure, we know that at this point at the corner, there is basically CH3. So it would be like this. And here, there's basically CH2. So it is going to be like this. And we have already discussed the reason that why it's CH3 here, because it has already made one bond here. And why it's CH2? Because it has already made one bond here and one bond here. So carbon can make maximum of four bonds. So there'll be two each that would be linked at this carbon. And this is oxygen. And here we have carbon, double bond oxygen. Okay. And here we will be having carbon. Okay, and one bond is there, one bond is there, one bond is there, so it is like C, only carbon would be there. Okay, because one bond is there and one bond is there, one bond is there. No, there would be CH like this. Okay, and here at bottom we will be having, at this point we would be having CH2. So it would be like this. And then we have CH3 at this corner. So it would be like this, like this, like this. And here we would again be having carbon double bond oxygen. And here we are just having amine group, and it would be like this. Okay.
Okay.
Mm. So let's move further and let's discuss about, there's another question. Now, they have given us a condensed formula, that is CH3, and no, it's basically not in bracket, it's CH3, and then we have oxygen, then we have in H and CH3. Now, what we need to do, we are going to draw its skeletal structure. We know CH3 would be at this corner. There is a double bond over here because carbon is having a double bond with oxygen at this point. And here there would be an H, and here at this corner there would be CH3. So this is going to be a structure like this. Now, there's another question. Now they have given us the condensed formula, that is CH3 COCl. Okay. So here would be CH3 at this point, okay, and so this at this point, and here we will be having a double bond with oxygen like this, and chlorine would be at its other end like this. Let's move towards the next question. That is CH3 whole cube, then is carbon CHO. And now we are going to first draw its displayed structure. I have told you yesterday that this bracket basically represent that there is basically a branch chain that is present with this carbon. So it is going to be like this. It's like this, and then we have a carbon. This CHO, that basically represent an aldehyde group like this. Okay. So
Okay.
that would be linked like double bond O and H. So this is basically the formula. Okay. So now there is another question. CH3, CH, CH3, CH2, 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 CH, CH3 at the branch. There's CH3 here. So let's draw its structure. How many carbon would be there? One, two, three, four, five, six, seven. It would be like one, two, three, four, five, six, and seven. Now, there is a branch at second carbon, and I have told you yesterday we can't draw it like this. We have to draw it at this path. You know what is the reason?
You said something like, um,
Because of the repulsion of
yes, the
electrons.
repulsion. Yeah.
Yes. So this was basically the reason.
Okay. So when you draw it in the structural formula, it doesn't matter what side you draw it on.
Yes, yes. Like,
So
mhm.
isn't it the same thing?
Yes, it's the same thing. So at sixth carbon, we are going to have another branch chain, and it would be like this. Okay.
Okay.
Now let's discuss about prefix, because now we are going to start with the naming. Okay. We are going to start with the naming of organic compound. So now we will be having the prefix, and prefix is basically the number of carbon atoms. Like for example, when we have one carbon, we will call it as meth. This is basically a prefix. When we have two carbon, we will call it as eth. When we have three carbon, we will call it as prop. And when we are going to have four carbon, we will call it as but. When we have five carbon, we are going to call it as pent. And when we are having six carbon, we are going to call it as hex. And seven carbon is basically hept. Eight carbon is oct. Nine carbon is no. And whereas 10 carbon is dec. Okay. Now let's discuss about, this is what we have done, prefix. Okay. Now let's move further towards suffix. What we mean by suffix? For example, if we are having alkane, if we are having alkane, its suffix would be ane. If we are having alkene, the suffix would be ene. If we are having alcohol, its suffix would be ol. And if you are having carboxylic acid, then its suffix would be oic. And if you're having like carbonyl compounds, okay, this carbonyl compounds, basically we have two carbonyl compounds. The one is aldehyde and the other one is ketone. The functional group of aldehyde is C double bond O dash H. And the functional group of ketone is, this is C double bond O. There is basically carbon on its both ends. Okay. Now we are having nitrile group. For nitrile group, it's basically C triple bond N. And for amine group, it's basically NH2. Let me discuss its you can say functional group as well. Alkene has no functional group, while alkene has a double bond that basically represents its functional group. Alcohol functional group is OH. Carboxylic acid functional group would be C double bond O dash OH. So this is whole about suffix. Okay, and I have not written their you can say suffix. Aldehyde suffix would be al. Ketone suffix would be on. Nitrile suffix would be just nitrile like this. Amine would be the same as its name. So Sultan, is that clear up till now?
Yes, sir.
Okay, great. So let's move further towards the naming of these organic compounds. So if we are going to discuss about naming of alkane, that is, this is carbon, this is carbon, this is carbon, and this is H, this is H, this is H, 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 and H. So there are basically three carbons, and we are going to name it as propane because it belongs from the group of alkane family, and that is propane. Now let's move further, and now we are having three carbons, and there is a double bond that is going to be present here. There will be three hydrogen as carbon has already made one bond here. So there will be two hydrogens here. No, it should be one hydrogen because there is a double bond next to it. There'll be one hydrogen here and one hydrogen here. Now it's fine. So we are going to call it as propene because it has a double bond and which indicates that it is basically an alkene. So let's move further towards the next question. first of all, we have to decide whether it's an alkane or an alkene. So, what do you think? It's an alkane or an alkene?
Alkene.
Yes, it's an alkene because of this double bond. And now, there is a thing from where we need to start numbering the chain. So we have to, we will always be starting this chain from the carbon which is nearest to the functional group. So functional group is basically double bond. If we are going to start from this place, this is one carbon, two carbon, and three carbon. But if we are going to start from this place, this is one carbon and second carbon. So it is closest from this place. So we are going to name it from this place. One, two, three, four, five. So first of all, there are five carbons, then it should be pent. And at which place we are going to have the double bond? That is two. So it would become pent-2-ene. Okay.
Okay.
Now let's move further to the next question. That would be, let's write it here. Now we are having basically two double bonds here. The one is at this place and the other one is at this place. So now we have to decide from where we are going to start numbering the carbon. So if we start from this place, one, two, and if we start from this place, one, which is closer to the functional group from the left hand side from this place? One, two, three, four, and five. So that five would become pent. And where does the functional group lies? The one lies at first place, pent one, and the second lies at third place, pent one, three. They are basically two functional group, two double bonds. So it would become pent one, three diene. Okay.
Is the double bond the functional group?
Yes, double bond is the functional group for alkene. I have told you this is the functional group for alkene. Alkene has no functional group.
Okay.
Okay, so now we are having five carbons. Okay, so first of all, we have to see from where we are going to start numbering the carbon atoms. We know they are basically two functional group. One is OH and this as another OH. So of course we are going to number the carbon atom from left hand side, one, two, three, four, and five. So how many carbon atoms would be there? There would be five carbon atoms. So that would
So it's
become
pent.
pent, yes. And uh, OH group is basically present at first carbon and at second carbon. So it would become pent 1,2-diol. Ol is basically the suffix for alcohol. Okay, so we are going to write it as pent 1,2-diol. Oh, there is another
It's three.
yes, so it is three.
It's
I have
pent
not
one,
seen.
two, three, triol.
Yes, triol. Okay. So there is another one which is at this place. So now it would become pent 1,2,3 triol. Yes. So there is another question. Okay. So first of all, let's start with their numbering. And they now we have basically uh, uh, two functional group present here. The one functional group is this, and other are this. Question may arise, which functional group should we give the first priority? So I'm going to answer it afterwards. First, you just remember this, that between alcohol and double bond, double bond is given the least preference. It should be given the least preference. In every case, it should be given the least preference. This double bond should be given the least preference. So if it would be given the least preference, then we are going to start numbering this carbon change from this place. 1, 2, 3, 4, 5, 6. So how many it would become hex? It would be hex. And first we are going to count that where does the double bond present? So it is present at this place and at this place. So it would be hex 3, comma 5 diene, and then it's the turn for alcohol. It would be 1, 2 diol. This is basically its name. Is that clear, Sultan?
Yes, just a question.
Yes, yes.
Is it is the prefix just hex or is it hexan?
No, it's just hexene. Okay, it's basically hex, and 3, 5, it would be diene. Okay, this is basically 3, 5, it would be
Okay.
diene, and 1, 2 diol. Okay.
Okay. So if it was just like hex diol, will we say hex diol or hexandiol?
We would be saying hex 1, 1, 2 diol.
Okay.
Yes, or we can say hexanol or hex 1, 2 diol. Okay.
Okay.
Hmm. So let's move further. Now, an important thing that I'm going to tell you about order of preference of group that you must need to remember if there would be one or more than one group. So first one is carboxylic acid. Carboxylic acid would be given the top priority. Then we have nitrile. We need to remember these things. Then we have aldehyde. Then we have ketones. Then we have alcohols. Hydroxyl. Then we have amines. They would be called as amino. Then we have double bond. So you have seen that double bond is given the least preference among all of them. Okay. So let's start with some aldehydes. Let's name them. Okay. So this is basically so first of all, can you please tell me that this is represents a functional group? Which functional group is this one?
Is this alkene?
No, this is aldehyde. This is aldehyde. I have already told you that functional group for aldehyde is C double bond O dash H. Okay, and the functional
Okay.
group for ketone is C double bond O dash C on this side and C on this side. There are some hydrogens over there. Okay, so you have to remember this thing that this represents the aldehyde. So how many carbons would be there? One, two, three. Prop. And where does we are going to name, we are going to start numbering the carbon chain from here. One, two, and three. So it would become prop one L. Okay, that would be prop one L. Is that clear?
Yes.
Okay. Okay. Wait. So now they are basically two functional group here. One, this one, and this one. Now, can you tell me this functional group is basically
This is aldehyde.
this is aldehyde, and this functional group is
Alkene.
alkene. Okay. So we are going to start numbering them from right side or left side?
From the right side.
Why we are naming it from right side? Why we are not naming it from left side?
Because the alkene has double bond has less preference.
Shabash. So we are going to start it from here. One, two, and three. So it would be prop. How many carbons are there? Sorry, there are basically four carbons. So it would be but. And where does this double bond lies? At which
On the
place?
third one. Three.
But 3 in And where does this aldehyde lies?
1.
So it would be butene 1L. Now, let's move further towards ketones. Now, let's discuss about ketones. Ketones are having, I have told you, it's double bond, and they are basically carbon on both sides along with some hydrogens. So we have this formula. This is CH2 double bond CH. Then we have CH2. Then we have C double bond O and CH3. Now, this group, this group is basically, can you please name this group?
This is a ketone.
This is a ketone. And can you please, this is basically alkene, you know it.
Yeah.
We are going to number them from right hand side or from left hand side?
From the right hand side because the ketone has more preference than the double
Very
bond.
good. 3, 4, and 5. So that would become pent, okay? Then pent, and where does this double bond lies?
Um, the double bond is 4.
Pent 4 and it would be 2 on. On is basically a suffix, okay?
Okay. Do we always write the double bond first?
Yes, 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 yes.
Okay.
Then we have another question, that is CH3, C double bond O, CH2, C double bond O, and CH3. Now, we have here we are going to have two ketones. The one ketone is at this place, the other ketone is at this place. So we are going to, we can name it either side. There's no problem. So I can like name it from this place, 1, 2, 3, 4, and 5. So that would become pent. And where does they lie? Because there is no double bond now. So I'm just going to name it like pent 2, 4, die on. Is that clear?
Yes.
Okay. So let's move further. Let's discuss about nitrile as well. CH3, CH2, 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 C triple bond, N. Now, we are going to name it from right hand side or from left hand side. Of course, we are going to name it from right hand side. 1, 2, 3, 4, and 5. So that would become pent, pentane, nitrile. Is that clear? And here,
Yes.
there is no need to mention number of nitrile. Or you can even mention it as well. Like pent 1 nitrile, that would also be fine.
Okay.
Because nitrile group would mostly be at the end. That is why we are not mentioning it. How many carbons would be there? One, two, three, four. So that would become bute. Okay. And where does this carbon lies? One, two, three. Third, bute three, ene, and nitrile. Okay.
Okay.
Now let's move further towards amine group. That would be CH3, CH2, CH2, NH, H. So amine group, let's discuss about this one. So how many carbons would be there? There would be three carbons. So that would become propane amine. No need to mention the group here as well. Okay. Now we have one more question, and that would be, you can say, the difficult questions that are going to start now. That is branched molecules and multiple function group. Would be like this: CH3, C, CH, double bond. We have C, CH3. We have C, double bond O dash H. Okay, so this is basically our question. And now, what we need to do first? First, let me just complete this chain as well. And this is OH, and this is CH, NH2, this is CH3. First of all, we need to find out which is the longest chain present here. First of all, let's find out the carbon. Carbon is here. This is carbon, 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 and this is carbon. So the longest chain, first of all, there are certain requirement to find out the longest chain or a main chain. Longest chain should have maximum groups attached to it. Maximum groups attached to it. To it. Okay. And second, what we need to do, we need to find out the chain which has maximum carbon double bond or carbon triple bonds. Third, we have to find out which one would be having maximum suffix functional group. So these are basically the requirements. Now, in order to find it, there is, first of all, there is a chain. You can see 1, 2, 3, 4, 5, 6. So it has 6 carbon atoms. But on the other hand, if you are going to see that there is basically this group, this group is basically aldehyde group. Okay. First of all, let's
Yeah.
mark them. This is aldehyde group, and this is alcohol group, and this is alcohol group, we call it as hydroxy group. And this is basically amine group that is attached to it. Okay, so uh, the longest chain is basically can be from this place, but we are going to choose from this place. 1, 2, 3, 4, 5, 6. The reason is that it has the aldehyde group as well, which is attached to it. Okay, so aldehyde group is there. That is why I'm choosing this as a longest chain. There's a question that arises in your mind that, sir, why you have numbered it from this place? 1, 2, 3, 4, 5, 6. You can even number it from this place. 1, 2, 3, 4, 5, 6. The reason is that because of the preference. We have already discussed this thing in preference part, yes, that if there will be aldehyde group or there will be amine group, then you are going to give the preference to the aldehyde group. So that is why we have chosen the numbering from there. Sultan, this point is clear?
Yes.
Okay. One more thing that I have not told you before is that uh, the thing that I want to explain you, just wait, please. Yes, that when we are having these order of preference group, these up till you can say up till this ketone, they are going to be added in suffix group. They are going to be added in suffix group. How? Let me show you. Okay, is that this point is clear? They are going to be added in suffix group. So how we are going to use it over here?
Yeah.
Let's see. Now, how many, first of all, let's find out how many carbons would be there. 1, 2, 3, 4, 5, 6. So that would be hex. And uh, how many double bonds would be there? Only one double bond, and that is this one. So hex 2 ene. I have told you that we are going to add some of them in the suffix group. So aldehyde is there. So I'm going to add this one in the suffix group. That would become hex 2 ene ul. Hex 2 ene ul. And where now let's move further towards the uh, this functional group. Functional group, we have this hydroxy group at fourth point, and we have amino group at fifth point. So this is amino group, and this is hydroxy group. So now we are going to name it according to the alphabetical order. So amine is at A. Alphabetically, it comes before, and the hydroxy group would be at, we will be choose it later. So amine group is at fifth. So that would become 5 amino, and that would become 4 hydroxy. So that would be the right answer for hydroxy, and there are basically two methyl as well. There is this one group and this group as well. There is methyl group as well. Now I'm going to name methyl as well. So that would become 4 amino, 5 hydroxy, 2, 4 dimethyl, 2, 4 dimethyl hex 2 ene ul. Sultan, is that clear?
Yes.
The main thing that I'm talking about is basically, first of all, that this would come in the suffix that I have told you here, that it would come at the suffix. Like if we would be having carboxylic acid group, nitrile group, aldehyde group, or ketone group, they would be the part of suffix. Okay, that we are going to put it over here. So that is why AL is there. And the other thing that I want to explain you is that now come towards the branch. Okay, functional groups. So functional group is here is methyl, this one, this one, and this one. And they would be arranged in alphabetical order. So amine, according to alphabet, that would come first, then hydroxy would come first, then methyl would come first. That would become 5 amino, 4 hydroxy, and 2,4 dimethyl, hex 2 in ul. Is that clear?
Yes.
Great. So now let's move further towards the next question, and that would be H dash C double bond O, and then we have COH would be there, and we have H group is here, and then we are having this CH, and then we are having CH2, CH2, C double bond O dash O. First of all, let's find out the where the chain would start. Let's find out first of all the functional group. So this is functional group. What this functional group to be called as?
This is alcohol, the OH.
No, that is carboxylic acid. Carboxylic acid. This is C double bond O OH. Okay. And
Okay.
now this is hydroxy group. And what this group is to be called as? Yeah,
This is aldehyde.
shabash. This is aldehyde. And now this group is ethyl. This group is ethyl. Okay. So first of all, let's find out which one is the longest chain. So longest chain would be from that would start definitely from this place because we know carboxylic acid has the preference. Okay, you can see
Yeah.
that carboxylic acid has the uh, top preference. You can see top preference. So we are going to start the chain from there, and let's see 1, 2, 3, 4. Even it would be 1, 2, 3, 4. So it would be same. But why I'm using this one? Because it has more functional group. It has one functional group here, one functional group is here. So now let's name it. So there would be 4 carbons. So it would become bute. Okay. And we know there is no ene. So it would become butane. 4L. Okay, 4L. This is carboxylic, this is aldehyde group, so it would become 4L. And carboxylic group is over here. So that would also come to, in the suffix side, and that would become oic acid. So that would become oic acid. It would have a greatest preference. And now let's move towards the branch. Okay, and let's discuss about the functional group. So it would be having ethyl group and would be having hydroxy group. And we know we are going to choose them alphabetically. So ethyl would come first. So it would become 2-ethyl and would become 3-hydroxy. 3-hydroxy. Butane 4-ol oic acid. Is that clear, Sultan?
Yes, sir. But since there's two ethyls, do we have to say like diethyl?
Where no, there is only one ethyl, Sultan. This is only one ethyl. Sorry, this is CH3. I have written it wrong. This is CH3. So this is ethyl group C2H5. Okay, this is basically
Okay.
alkyl group. Alkyl group. How alkyl groups are made? Like for example, this is methane and it is CH4. When we subtract H from it, it would become CH3. So it would be methyl. Is that clear?
Yes, yes.
So this is basically what I want to tell you, and I'm going to send you some of the questions related to it, and then you have to solve them. Okay?
Okay, okay.